So example number 2, use Euler's method to obtain a numerical solution of the differential equation dy dx plus y is equal to 2x, given that the initial conditions are at x is equal to 0, y is equal to 1, x is equal to 0, y is equal to 1. For the range is from 0 to 1, and the interval is 0.2. Draw the graph of the solution in that particular range. So I want us to fill the table so that we have values that will help us draw the graph. So the table I want us to fill is of values, just like the other one, solution. I want us to fill the values for x naught. I want us to fill the values for y naught. And I want us to fill the values for y prime naught, guys. So we've been told that the values of x naught is equal to, so from the range, x is equal to 0. So the initial condition is that where we are starting is that x is equal to 0. So our x naught is what? Our x naught is 0, guys. And if our x naught is 0, what is our y naught? Our y naught is 1. So that those are values that we already given. So what is our y prime naught, guys? We already have our dy dx here, so we can be able to evaluate that. And I want us to evaluate for all the values. I can do the y prime naught maybe somewhere here so that you see. If this is our y prime, then our y prime naught basically involves us replacing the values of y with y naught and x with x naught. So our y prime naught, so guys, we have x, our y1 is given by y naught plus h y prime. That is from the Euler's formula. So if we replace the values here, we will have 1 plus 0.2 into minus 1, which is our y naught prime, if we replace values there. So our y1 will be given by what? This will be 0.8. That's our y1. We can easily get the value for y prime here, because if we make dy dx the subject of the formula, dy dx will be equal to 2x minus y. And x naught is what? X naught is 0. So 2, 0 will be 0 minus y naught is what? So y prime of 0 is obviously minus 1. That's why you see it as minus 1 here. So I've already given you all these values. So can we continue to get the rest of the values? So this is minus 1. So now, since our interval is 0.2, can we have the value of x naught as now 0.2? So for x naught is 0.2, what is the value of our y naught? Guys, what is the value of our y prime naught? So evaluate that. Okay, fine, guys. So to get y prime of 0, so I'll just continue with it here so that you're able to see as I fill in. So you know that y prime is equal to what? We know that dy dx is equal to 2x minus y from whatever we were given. So what is y prime of 0? So it will be given by 2 into x. What's our value of x right now? 0.2 minus what's our value of y right now? 0.8. That's what we are doing. So I don't know how hard that is for you guys to do and tell me the answer from the calculator. So our y prime of 0 at this instant, if you evaluate this, you will get it to be minus 0.4. Then let's continue. Interval is 0.2. So from 0.4 to 2, we go to what? 0.4. So at x naught is 0.4. What is our y naught? Our y naught. So our y naught is 0.8. So can we fill the table? The formula is y1 is equal to y naught plus h y naught prime, guys. So what's our y1 in this particular case? Our y1 will be equal to y0, and our y0 is 0.8 plus h, our h is 0.2, multiplied by y0 prime, and our y0 prime is what? Minus 0.4. Minus 0.4. So what does that give you for our y1? If you evaluate that, what do you get? This will give you 0.72. 0.72. So 0.72 becomes our new y0 here, 0.72. And if we have this as 0.72, we also have this. So how do we get this one? From this equation again, our dy dx is equal to 2x minus y. So we have 2 into, what's our value of x at this instant? 0.4 minus, what's our value of y? 0.72. So what do we have if we replace those values? This will give us 0.08. So here we will have 0.08. Let's continue. Our interval was 0.2. So and we are going from 0 all the way to 1. So I have 0.6 to fill. I'll do 0.6, then I hope you guys can now do 0.8. So if I have 0.6, then what's my y1, guys? My y1 is equal to, I don't want to repeat the formula, y0. What's my y0? 0.72 at this juncture. So 0.72 plus h, which is 0.2, multiplied by y prime naught. Y prime naught here is 0.08 from the table, 0.08. So if you evaluate this, what do you get as your new y1 here? If you evaluate this correctly, so this is 0.72 plus 0.2, 0.08, that should give you 0.736, 0.736. So in a similar manner, you can get this using this here. So guys, can you continue and tell me the values for the rest of the table? I hope that should be clear.